Okay, so today's topic will be equations of the line. Continuation of chapter 5, coordinate geometry in the xy plane. Okay, so you can check it in your teaching notes from page 79 to 90. So let's recall first. You can write the equation of a line as y is equals to mx plus c, where your m is the gradient and 0c is the y-intercept. Or you can also write your equation of the line as ax plus by plus c is equals to 0, or a, b, and c should be integers. Let's also recall that to find the value of your gradient, y2 minus y1 over x2 minus x1 if we have 2 points. Okay, now in some of the questions in your teaching notes, you will be encountering this one. Meets the x-axis. So what do you mean by this case? When you say meets the x-axis or the x-intercept, you just let your y to be 0. If it says meets the y-axis, you need to identify the y-intercept. You can find it by letting your x to be 0. Let's apply this in the next example, number 1. Now, line 5x minus 4y plus 20 equals 0 meets the x-axis at point A. So that means at point A, we want to find the coordinate of E where it meets the x-axis. And then, the same line, it meets the y-axis at point B. So we need also to find the coordinates of B. So work out the coordinates of points A and B. Now, to find the coordinates of A, from your equation of the line, 5x minus 4y plus 20 equals plus 20 equals 0. Meets the x-axis, meaning your y is 0. So we just let our y to be 0 here. 5x, if y is 0, so this whole thing will be 0. Minus 4 times 0 is 0. So we have 5x plus 20 equals 0. So 5x is equals to minus 20, dividing both sides with 5. So your value of your x will be minus 20. Minus 20 over 5, which is minus 4. Okay, so the next one, we want to find the coordinates of B where it meets the y-axis, meaning your x here is equals to 0. So the same thing, 5x minus 4y plus 20 equals 0. X now is 0, so 5 times x will give you 0, so you only have minus 4y equals minus 20. Divide both sides with minus 4, so y will give you 5. Hence, the coordinates of B will be 0, 5. X is minus 4, wherein y is 0. For this one meets the x-axis. And then for coordinates of B, y is 5 when your x is 0. Okay, let's continue. So to identify, so here we will gonna focus on the equation of the line. So there are two formulas, gradient point form. So if the given is an M and a point, so this will be the formula. y minus y1 is equals to m times x minus x1. But if the given are 2 points, p1, x1, y1, p2, x2, y2, so you will apply this formula. Okay, let's have examples. Now here, find the equation of the line with gradient minus 2, so meaning m is minus 2. That we have 1 point, 2, 0. So this is your x1, y1. So we have the following given. M is minus 2, x1 is 2, and y1 is 0. In this case, we have a gradient and 1 point, so you will use this formula. Putting the values, so you will have y1 is 0, m is minus 2, m is minus 2, x1 is 2. So simplify, you will have, multiply this minus 2 here, this here, so you will have y minus 0 is y, it's equals to minus 2 times x minus 2x, minus 2 times minus 2 will be plus 4. Or you wanted to write in this way or the other way around, where everything is on the left side. Remember, there are 2 equations of the line, either into mx plus c, or the other one, ax plus by plus c is equals to 0. So you can write your equation in this form or in this form, so it's up to you. Let's have another example. So find the equation of the line that passes through, so the same thing, m is given and 1 point, so we will use the first formula. Plotting the values, so y1 is 2, m is 5, x1 is 3. Simplify, so y minus 2, 5 times x, 5 times minus 3, minus 15. So you will get, this one, the equation of the line, or all together on the other side. Minus 15 plus 2 will be minus 30. So either this one. Okay, let's have another example. So this is formula 1, right? Formula. So we are using formula 1. Okay, let's have example number 4. Find the equation of the line that passes through the points. So we have 2 points, so therefore we need to use the formula number 2 because we have 2 points. So x1 is 2, y1 is minus 2, x2 is minus 3, y2 is 2. So we will use formula 2. Okay, putting all the values, y1 is minus 2, minus minus will give you plus 2, y2, 2, y1 minus 2, so 2 minus, so plus 2x minus 2, x1, x2 is minus 3 minus 5. And then we cross multiply this one, so minus 3 minus 2 is minus 5, multiplied by y plus 2, 2 plus 2 is 4, multiplied with x minus 2. And then we simplify them, remove the brackets, by multiplying minus 5 here, by multiplying 4. So minus 5 times y, minus 5y, minus 5 times 2, minus 10, 4 times x, 4x, 4 times minus 2 will be minus 8. So either you put everything on the right, you put everything on the right except y, or this one where everything is on the left side. So 2 things. Okay, after this you simplify and write them into this form, into y equals mx plus c form, or the ax plus by plus c form. Okay, so let's have another example. Find the equation of a line that passes through the points. So 2 points, 4, 0, and minus 3, 3. So again, there are 2 given, 2 points. So we will use formula number 2. Plot all the values. So y minus your y1, which is 0, y2 is 3, y1 is 0, x minus your x1, which is 4, your x2 is minus 3, minus x1, which is 4. So you will, after this, you cross multiply. Y minus 3 minus 4 is minus 7. Y minus 0 is y. 3 minus 0 is 3 times x minus 4. And then we simplify by removing the brackets. We multiply minus 7 times y, minus 7y. 3 times x, 3x, 3 times minus 4, it's minus 12. And then we simplify this by writing into the equation as y equals mx plus c, or the other one, the ax plus by plus c, is equals to 0. So you will get either this or this one. Okay, so let's move on to the next equation. But we need to recall first parallel and perpendicular lines. Remember, 2 lines are parallel. Line 1 is parallel to line 2, meaning they will never meet at all if the gradients are equal, parallel. Now, they are perpendicular, line 1, perpendicular to line 2, meaning 2 lines where they intersect, they meet at one point, forming 90 degrees, so they are perpendicular. If when you multiply their gradients, the result should be negative 1. So, for the following examples, work out the gradient of the line that is parallel to the lines with these gradients. So these are the gradient of the other line. And then we wanted to find another line which is parallel to this. So in this case, if it is parallel, so that means if the gradient for line 1 is 3, meaning the gradient for line 2 should be same. If the gradient is 1/2 for the first line, the gradient of the other line should be same. If the gradient is minus 2/5, therefore the other line should also be the same because they are parallel. However, if the word is perpendicular, same given, so how can we find the other line? So we need to remember gradients should be the same, or to find the second gradient, that means minus 1 by the given gradient of the first line. So for letter A, so the gradient for the first line is 3, therefore the other line is minus 1 by the gradient of the first line. So the second line will be minus 1/3. For letter B, so the given gradient is 1/2. We will find the perpendicular for this. So minus 1 by 1/2, it is minus 2. If it's minus 2/5, so it is perpendicular. So you apply minus 1 by the gradient of the first line. So you will have 5 by 2. So remember, if they are parallel, the same gradient. If they're perpendicular, so we need to get minus 1 by m1. So parallel, same. Parallel. If perpendicular, apply this rule. Okay.